Hey, did you know that the sun alone, in a time span of 1 hour, produces enough energy that can sustain all the energy needs on Earth for an entire year? But what if we tell you that this same energy can now be harnessed on our planet as well? And no, we are not kidding. This really has happened. Germany's Max Planck Institute for Plasma Physics, IPP's scientists have built a nuclear fusion reactor that can produce energy just like the sun does. And do you have any idea how huge this is? Well, this reactor, which is 5 meters in height and 15 meters in diameter, has the potential to create highly powerful nuclear energy. Who knows, if this technology continues to develop, then it can mark a turning point in the world of science and technology. Since it is so highly powerful, it can also fulfill all the energy needs on Earth. And if this happens, then it will open doors to so many other opportunities that are otherwise only dependent on the energy that we receive from the sun. With the help of such technology, we can create huge spaceships by producing energy on our own without depending on any star. We can also become an interstellar space traveling civilization. This sounds great, right? Have you ever thought about how it is possible to create such a magnificent amount of nuclear energy? In order to create or replicate the energy of the sun, first we have to understand more about its nuclear reactions. To begin with, we need to know whether it is the sun or any star for that matter. The most abundant element present in them is hydrogen. Due to immense pressure and temperature within the stars, the hydrogen atoms ionizes. The protons of 2 hydrogen atoms fuse together. Now the most interesting part is that when the scientists tried to replicate this energy, they discovered something. After the fusion, the mass of the new atom that is created is less than the mass of its individual particles. During the process of collision of 2 atoms, some part of it is released as energy. That is how this nuclear fusion energy is created. Through this process of nucleosynthesis, 2 smaller nucleus of light elements lead to the creation of a new atomic, heavier nucleus. Do you know what's even more fascinating? All the heavy material elements that are present in the universe were once formed in the stars. So it won't be completely wrong to call yourself a stardust soul, because all the atoms and elements in your body were once a part of some star that might still be in the universe. Well, let me tell you that it's not the first time that a nuclear reactor has been constructed. Back in time, in the year 1940, nuclear fusion was used to create world's first life-endangering thermonuclear hydrogen bomb, and it was prepared by the year 1952. But this fusion energy has not been used yet to provide for more sustainable development of mankind. Now that Germany has come with this great invention of the nuclear fusion reactor, we are moving towards achieving a better sustainable living for our civilization. So, the name of this reactor is the Wendelstein 7X, also called W7X. Anything as powerful as this needs a very long time for its completion. It took 19 years for the scientists to come up with its unique design. Its purpose is to advance stellarator technology. Though this experimental reactor will not produce electricity, it is used to evaluate the main components of a future fusion power plant. It was developed based on the predecessor Wendelstein 7AS experimental reactor. After 2 successful operation phases ending in October 2018, the reactor was taken offline for upgrades. It resumed its operations in autumn 2022, gradually increasing power and working towards the goal of maintaining enclosure for up to 30 minutes of continuous plasma discharge, thus demonstrating an essential feature of a future fusion power plant: continuous operation. Unlike the current nuclear fission technology, nuclear fusion does not produce any long-term radioactive waste. For physicists, this is not less than a holy grail, as this fusion reactor can become an endless source of clean, renewable energy if successfully exploited. It has enough energy to power the stars, and it can offer practically infinite energy with 0 carbon emissions. This fusion reactor has many advantages, and it is, in many ways, better than nuclear fission. But now you must be thinking how it is possible to withstand such an enormous level of heat, as no materials exist that can endure direct contact with such heat. Another mind-boggling question is, how is this energy contained? Well, the answer to this question has certainly been given by the scientists in Germany's Max Planck Institute for Plasma Physics. So, to achieve fusion in a lab, scientists have devised a solution in which a superheated gas, or plasma, is held inside a donut-shaped magnetic field. Scientists produce this hydrogen plasma in a device, and this device is known as Wendelstein 7X stellarator. The hydrogen atoms are smashed and blasted with microwaves until the temperature reaches 100 million degrees. Do you know where else this same amount of energy is produced? This whole process reflects what occurs at the sun's core. In fact, it is 7 times the temperature of the sun's core. So now do you know how powerful this can be? Among other things, this Wendelstein 7X has a really bizarre structure. There is a dizzying number of twists and turns in which the plasma is contained using a magnetic field. This device, called a stellarator, uses a complex 3-dimensional arrangement of coils and loops to control the flow of hot plasma through the device's loops, keeping it stable. This large-scale optimized stellarator gives the appearance of a donut. It is one of the most complex engineering models ever devised. As it turns out, this shape is inspired from the first ever stellarator. The first stellarator, invented by astrophysicist Lyman Spitzer at Princeton University in 1951, did it by bending the tube into a figure-8 shape. But the lab he set up, the Princeton Plasma Physics Laboratory, PPPL, in New Jersey, switched to a simpler method for later stellarators, winding more coils of wire around a conventional torus tube like stripes on a candy cane to create a twisting magnetic field inside. As it appears, this nuclear fusion reactor is more like a tiny star. Although scientists tried to make it simpler than before, these fusion reactors are still very hard to build, and even more prone to cost overruns and delays than other fusion projects. The leader of the German effort, Thomas Klinger, says that no one imagined what it means to build one. Most certainly, this was an inconceivable idea, given its peculiar structure. David Gates, head of stellarator physics at Princeton Plasma Physics Laboratory, Gates says that the world's waiting to see if we get the confinement time and then hold it for a long pulse. The key measure is energy confinement time, the rate at which the plasma loses energy to the environment. This certainly is a major breakthrough in the field of science and technology. Nuclear fusion has potential beyond what you can imagine. It can offer practically infinite energy with zero carbon emissions if it can be recreated on Earth. Such advanced technology was only a part of imagination and was beyond our reach. But today, as we see this happening and turning into a reality, we can see how billions of dollars continue to flow into the field. It is one of the first new breed supercomputer designed stellarators to have had most of their containment problems computed. The success of W7X gives the researchers hope that the next generation of fusion reactors will be able to reach that limit. Science is now getting so close to the great objective of fusion power. Scientists have inched closer to this reality. Imagine all that can be done if such powerful fusion energy can be harnessed. This nuclear fusion energy is a promising long-term option for sustainable global energy supply. The world is desperately in need of such instruments that have the potential to provide cheap and endless energy without emitting carbon into the air or dumping radioactive waste into the environment. And this nuclear fusion reactor developed by Germany's IPP scientists is a wonderful reward of so many years of research work that has the potential to change the world completely. Energy is the fuel that runs this world, and generation of fusion energy is definitely a major accomplishment for mankind. There are endless opportunities to unlock with such highly powerful reactors. What do you think? Can we get there? And create a sustainable living for all beings on this planet?